Hi, this video is going to take you through your day 2 worksheet. So we're going to start off with some basic recap of the rules that we talked about previously. We know that when we are multiplying two bases together, bases are what's attached to the exponent. So the A and the A are both A's, and because they're the same base, we can keep the base, and if you're multiplying your base, you add the exponents. So 7 plus 9 would be A to the 16th power. For number 2, you have the same base, so we are going to keep our base and we are going to subtract the exponents when we divide. So 3 minus 1 would be x squared. In number 3, you only have one base, and when you have one base but multiple exponents, you keep the base and you multiply. So this would be 3 times 15. I lied, that's 3 times 5, which is 15. For number 4, you would have to distribute the exponent up top. That would be x squared over y squared. Now we know that if something is in the numerator and the denominator, you can cross them out because they reduce to 1. And you're just left with the x squared. For number 5, when you distribute that exponent, the negative is on the inside, and we know that a negative to an even power is positive. So the negative goes away, and this becomes x to the 4th, y to the 4th. For number 6, your base is 7. And we are going to keep the base and subtract exponents. So this is c minus d. This is not 1 to the c minus d. You can't divide the 7 because the 7 has the exponent. For number 7, these are not the same. And if they are different bases, then you can't combine them. This is just x to the 5th, y to the 3rd, not xy to the 15th. For number 8, you're going to work with the x's first. 6 minus 4 would be x to the 2nd power. I'm subtracting because we're dividing. Then you're going to work with the y's. We're going to keep our base and subtract the exponents. This is going to be 3 minus 1, which is y squared. Keep in mind that you could choose to write this as xy squared. All right, we're going to learn two more rules in this video. We are going to learn what to do when we have 0 exponents and negative exponents. So it is important to know our vocabulary first. The base is what is on the bottom of the exponent, and the exponent is what is up top, that little top piece. And you need to be really careful with how you write it. For example, we have x squared is the correct writing, but x with a large 2 is incorrect. So the 2 is too large here, and this is no good. So please make sure in this unit you are writing your exponents up top and really tiny. We also call an exponent a power. So we know that when we're multiplying, we add exponents. When we're dividing, we subtract exponents. When we have a power to a power, that's an exponent to an exponent, you multiply the exponents. However, you can only apply these rules if the bases are the same. And if you need some time to copy that down, pause the video, copy it, and resume it when you're done. All right, so going on to 0 exponents. We're going to simplify this 2 different ways. The first thing we're going to do is we're going to simplify this using the division law. So the division law tells you to keep the base and subtract your exponents. We know that 2 minus 2 is y to the 0 power. Now, if you were to simplify that by reducing, y squared divided by y squared, something in the numerator crosses out with something in the denominator. For example, 3 divided by 3 is 1. 4 divided by 4 is 1. Negative 8 divided by negative 8 is 1. So y squared divided by y squared, something divided by itself, is 1. So the thing is, when we did the division law, we got y to the 0, and when we simplify by reducing, we got 1. So basically, what we say is the rule for zero exponents is that anything to the 0 power is 1. It is sometimes hard to tell what your base is. Only your base goes to 1. So actually, I do want to talk about some things that people tend to ask. So if you have x squared over x squared, which is, let's see, x to the 2 minus 2, which is x to the 0, we know that this is 1. And if that's really not making sense to you, do it with numbers. If you had 3 squared over 3 squared, that would be you keep the base and you subtract your exponents. So 2 minus 2 is 3 to the 0, which is 1, because anything to the 0 power is 1, right? But the reason for this is if you simplify, 3 squared is 9, 3 squared is 9, 9 divided by 9 is 1. I just want to point out, when we say anything to the 0 power is 1, we are saying anything except 0. 0 to the 0 power, your calculator is actually going to give you an error because it stems back to this division, and you can't do 0 divided by 0. And if you didn't get that, don't really worry about it. What is important is negative exponents. So if we divide with the division law, you keep your base and you subtract your exponents, top minus bottom. This would give me x to the negative second power. Now, if we were to expand and simplify, what they mean here is that this is 3 x's. So we have x times x times x, 3 times. And then in the denominator, we have x times x times x times x, oh my god, times x. We know that we can cross things out if they're in the numerator and the denominator. So these cross out, these cross out, these cross out, and you're left with a 1 up top. Because what we're doing is we're dividing. X divided by x is 1. It doesn't just disappear. So we are left with 1 over 2 x's. This simplifies to 1 over x squared. So x to the negative second power is equivalent to 1 over x squared. That's a little weird, but basically what happens is a negative exponent flips it. It takes the reciprocal. And then once you take the reciprocal, it becomes positive. So to make an exponent positive, you bring it to the denominator. If it's already in the denominator, though, you're going to bring it to the numerator. So what they mean by that is if you were to have, as a separate example, if we were to have 1 over b to the negative 3 power. In this case, your b is already in the denominator, so we are going to bring it to the numerator, and you get b to the positive 3rd power. But anything in the numerator, anything divided by 1 is just itself. You don't need the denominator of 1. This one people don't tend to like that much. We will practice it. Pause the video if you need more time to copy this. So the first 4 expressions are going to work with your 0 power rule. And it's important to identify the base and the coefficient. So your base versus your coefficient. Your base here, everything in parentheses is your base. The coefficient is the one in front. So what's happening is that this whole thing goes to 1. Any base to the 0 power is 1. Because your base is -4, the whole thing goes to 1. For the next one, your base is not -4. The only thing attached to the exponent is 4. And then your coefficient is -1. So yes, the 4 to the 0 goes to 1, but we still have the -1 in front. So this would be -1. For the next one, your base is 3x. The coefficient is 1. So because you have 3x to the 0 power, that whole thing becomes 1. Plus there's already a 1 in front, so everything is 1. Whereas in the next one, the only thing attached to the exponent is x. The 3 is the coefficient. So the 3 doesn't get touched because the 3 doesn't have an exponent. But the x gets touched, and because the x has a 0 exponent, it becomes 1, and 3 times 1 is just 3. All right, trying the next example here. We want to rewrite each expression with a positive exponent. Pretty typical on the regions. They really won't leave negative exponents in your answer. So if you have a negative exponent, you flip and make it positive. Right now we have a over 1. So this is going to become 1 over a. You're going to bring the piece with the negative exponent to the denominator, and then you're going to make it positive. Right now, we have a negative exponent in the denominator, so you are going to bring it to the numerator. We have x to the positive 4 over 1. Or you could just write x to the 4th. Now, I want you to pay attention to number 7. Your base, what's attached to that exponent, is x to the negative, your base is just x. So if the base is the x, then only move the base. In other words, only the x gets moved to the top. The 3 stays where it is. So everything that doesn't have an exponent stays. We have 1 over 3. No exponent, so it stays in place. But from there, the x has to move because the x has the negative exponent. And when you move it, the exponent becomes positive. You can simplify this to x squared over 3. For the next one, your base is just y. So because the y is the only piece with the negative, you are going to move it. If it's in the bottom, move it to the top. If it's at the top, move it to the bottom. The x stays where it is because the x has no exponent, so you're going to leave it alone. But the y is going to come to the top, and it's going to become positive. If you would like, yes, you did have a denominator, there would still be a 1 there in front of it, or you could just write it as xy squared, don't care. Now, in the last one, your base, because of those parentheses, everything is the base, the 3 and the a. So when you flip this, the 3 and the a both have to go to the denominator. This becomes, this becomes 1 over 3a cubed. And from there, what you can do is you can distribute that exponent. So this would really become 1 over 3 cubed, a cubed. And we know that 3 cubed, or hopefully we know that 3 cubed is 27 as your final answer. Okay, we have a few more examples left. I just want to talk about this regions problem. Again, when you have these problems where they're complicated fractions, simplify the numerator first, simplify the denominator, and then actually divide. So what you are going to do is you are going to multiply those values. If you have one base, that is the power to power rule. You multiply your exponents. So if you were to multiply your exponents and distribute the 3, you get b. 2n times 3 is 6n. 1 times 3 is 3. In the denominator, you are multiplying, so you're going to add. So 1n plus 4n is going to be 5n plus 3. Now that you're dividing, you are going to subtract. So you keep your base and you subtract. 6 minus 5 is 1n. 3 minus 3 is 0. This is just b to the n power. We'll get better at it as we continue practicing. Actually, I'll just do that quickly. Over here on the left-hand side, you have one base with multiple exponents. So you multiply. This would be 3 times 2 is 6. If you want to get a by itself, perhaps you should divide by what's attached to it. So if you were to do that, the x to the 6's cancel, and you get x to the a equals, let's see, 10 minus 6, because you would subtract, that would be 10 minus 6 is 4. So this would tell me that a is equal to 4 because the exponents have to be the same value. All right, we are going to practice using only positive exponents. When you see a negative exponent, flip it. We have 1 over c to the positive 100. You flip and make it positive. Now, for the next one, the 3 is going to stay where it is because only the a has the negative. So only the a goes to the denominator. And when you move it to the denominator, you make it positive. For the next piece, imagine this was a fraction. Only the y has the negative exponent, so only the y goes to the denominator. The 5 and the x cubed stay because they have positive exponents or no exponents at all. When you move it, make positive. For this one, only the x has the negative. So the 1 and the 5 stay, but the x comes to the top and becomes positive. You don't need to write the 1 in front. Now, the y and the 3 have nothing, so don't touch them. But the x has negative, so you move it to the top as a positive. Now, you could put it in alphabetical order if you want, but it's not necessary. You could really do whatever you want with that. For the next one, what's important is you have 2 exponents. When you have 2 exponents, you multiply. So 2 times 3 is negative 6. Now that you have a negative exponent, move it to the top. You have 3x to the 6th. You could write over 1 if you wanted to, but it's not needed. Okay, we're going to do just these examples, and yeah, we're going to do just these examples, and then we're going to call it quits. They want you to write all of these without a denominator. We just need to be careful when doing things. If you want it without a denominator, you need to move the denominator up. So, for example, our 5 and our x cubed are fine. Don't need to touch it. They're already in the numerator. But if you want to move the y to the top, anytime you move an exponent, you make it the opposite value. So if it was negative and you moved it, it would become positive. But if it's positive and you move it, it becomes negative. For the next one, let's see what we get. You're dividing, so you're just going to subtract your exponents. So we have a to the 1 minus 5, b to the 2 minus 4. If you simplify that, you have a to the negative 4, b to the negative second power. Done. Because they don't want a denominator, but this could be 1 over a to the 4th b squared. For number 11, before you subtract and divide, you need to distribute that exponent. And when we distribute exponents, we multiply. So this is x to the 3 times 3, which is 9, and then y cubed. This is x to the first, y cubed. Now remember that if something's in the numerator and the denominator, they cross out, because 3 minus 3 is 0, and anything to the 0 power is 1. From there, you're just going to have x to the 9 minus 1, which is x to the 8th. For the next piece, 125 divided by 4. I don't know what 125 divided by 4 is. So we have, I'm going to put this in as a fraction, alpha y equals 125 divided by 4. That's why I didn't know what it was. It turns out that 125 divided by 4 is not a nice number. So because it's not a nice number, you're just going to leave it. If you can't simplify the fractions, let it be. But what you can do, oh, it said to write it without a denominator. Oh, interesting. I guess if it says to write it without a denominator, then you really would have to write it as a decimal. So the decimal is 31.25. We don't typically do that, but I guess we're going to do it now. You're going to subtract your exponents. We have a to the 3 minus 2 is 1. And then you have the b, because that b really goes in the denominator because there's nothing to compare it to. And this b has a 1. Now, it did say write it without a denominator, which means we're going to have to move the b to the top. And in order to move the b to the top, if you are switching the position, you need to negate the exponent. So this would be b to the negative 1. You could write a to the positive 1. It's not needed, but you do need an exponent of negative 1. Okay, 2 more. For the next one, we have 2 minus 6 is c to the negative 4. Then we have d1 minus 7 is, that looks like a z. I don't like that. There we go. 1 minus 7 is d to the negative 6. All right. But those are negatives, so they need to become a fraction. Actually, no, they don't need to become a fraction. I'm so used to writing this without negative exponents, but it says without a denominator, so I guess we're done. Easy. Distribute your exponent by multiplying. We have 4 times 2 is 8. We have 2 times 2 is 4. And from there, subtract. So 8 minus 3 is 5. And 4 minus 10 is negative 6. There we go. So hopefully this video gave you a better idea of what to do when you have negative and zero exponents. We will be practicing with them next time.